Hi, my name is Akhil and I'm a professional mechanical engineer working in a petrochemical company in Middle East. I take this opportunity to thank all viewers of this video, hoping that you will like it. Please don't hesitate to put your comments about the video in the comment section. This video will be first in a series of videos that I'll be uploading sequentially on the subject of ASME Section 8 Division 1. The idea behind this is to convey the topics that are usually covered in, let's say, about 5 days or a 40 hours classroom training. As you know that these trainings are usually so costly, making it almost difficult for an individual via self-funding. Instead of long videos, I'll try to cover the topics in small video clips lasting about 10 minutes or so, but obviously some videos may be longer as an exception. So, following are the topics that I will try to cover in this series of videos. As you can see, the first two topics are related to introduction and background to the code and the engineering principles behind it. As you can see, the other topics are sequenced in the same order as they are in the code itself. Starting from material consideration, design condition and loading, thickness calculations, openings and reinforcements, nozzles and other attachments, fabrication and tolerances, forming procedures and joining methods, heat treatment and NDE, inspection and testing, marking and certifications, then the pressure relief devices, followed by subsection B and C, which are related to fabrication and material class, then the appendices, and some popular pressure vessel softwares, and finally advanced pressure vessel analysis, tools and techniques. So, as the name suggests, pressure vessel is a container for pressurized fluids, that is liquids or gases. But here the term pressure implies that vessel is not at a pressure that is atmospheric or ambient, although it may be in vacuum service. And further to this, vessel may go through atmospheric conditions during its operation, but it is not specifically designed for atmospheric conditions where other storage tank standards such as API 620 and API 650 are more relevant. They are widely used in various industries such as refining and petrochemical, chemical and fertilizer industries, power industry, paper and pulp, food or pharmaceutical industries, and many other industries. And according to ASME Section 8 Division 1, pressure vessels are containers for containment of pressure, either internal or external. This pressure may be obtained from an external source or by application of heat from a direct or indirect source, or any combination thereof. So, source of pressure can be internal, that is, through the pressurized fluid that are contained inside this vessel, or even external, such as external forces or vacuum outside, or by the application of heat from a direct source, which can be a direct firing inside the vessel, or an indirect source, means which can be produced through some interaction or some heat exchange. Pressure vessels can be classified in a number of ways. First is due to function. It can be a simple vessel or a storage tank, a heat exchanger, or even a reactor. Then due to geometry, it can have a cylindrical shape or a spherical shape or a rectangular shape, or even you can have a cylindrical shape with a conical transition. Due to metallurgy, it can be ferrous metallurgy, that is, it has iron as its basic constituent, non-ferrous and even non-metallic. Then according to manufacturing or fabrication method, it can be a welded, forged, brazed or a combination of these. According to orientation, it can be a horizontal vessel or a vertical vessel. And based on insulation, it can be a fixed or a mobile vessel. And mobile is that it is mounted on either truck or train or even ships. And finally, location, that is onshore and offshore. Generally, pressure vessel components are categorized as pressurized and non-pressurized parts. Pressure components include shell, heads, or nozzles. Non-pressure components include supports, can be saddle type, skirt, legs or a lug, external attachments, pipe support clips, ladder clips, etc., and internal such as vortex breakers, tray support ring, etc. Although these internals are inside the vessel, but in most cases they are not the main pressure containment parts. Shell is the primary component that contains pressure. Usually it is a curved shape, that is can be cylindrical, conical or spherical. Vessel shells are closed by heads. Components typically are welded together, but other methods are also used for joining. Multiple diameters, thicknesses or materials are possible. Saddle supports are used for horizontal vessel, whereas skirt, legs or lugs are used for vertical vessels.